מתחילה. אז שלום לכולם, היום יום שני, 31 למאי, מדהים איך הזמן עובר, אנחנו כבר מאוד מתקדמים, ולקראת הסוף אפילו של הסמסטר. עוד מפגש של הקולוקיום, והפעם עם יונתן, אז מעביר ישר מיד ובלי יותר מדי סיפורים את השרביט ליונתן. אני אשתדל להשתיק את מי ששוכח לסגור את המיקרופון שלו, על מנת שנוכל לשמוע כמו שצריך, אז סליחה מראש, ויונתן, קדימה, הבמה שלך.
תודה רבה. טוב, אני אעשה את השיחה הזאת באנגלית. אני אשתף את המסך. רואים? הכל בסדר? כן? טוב. Hello everyone, my name is Jonathan Dortheimer, and it is my privilege to present you with the ongoing research project. I'm a postdoctoral fellow at the MTRL Lab, directed by Professor Aaron Sprecher, in collaboration with Professor Wendy Ju from Cornell Tech. We started this project 3 months ago by forming an international research group from the US and Europe. While the COVID-19 pandemic affected our ability to travel, it facilitated digital communications in a way that makes such a global effort possible. The research is conducted in collaboration with Cornell Tech, Carnegie Mellon University, and Munich Technical University. I am presenting you this early research project to update you on the work that we do at the lab and initiate a discussion. Recent breakthrough in AI allow the research of automation in architectural design. However, architectural design is highly complex and dependent on the interaction and collaboration with clients and professionals. Our project aims to explore methods to integrate AI in a human design process. In this talk, I will first present the theoretical background and motivation to develop AI for architectural design. Then I shortly review the relevant AI capabilities. I will present our human-centered AI design model. Then the research method will be presented. And lastly, we will discuss research potential and outcomes and the preliminary results. So, how do we define AI? Russell and Norby in the textbook define AI as the research field that is concerned mainly with developing machines capable of rational action, namely an ideal intelligent agent that takes the best possible action in a situation. As a counterpoint to Russell and Norby's optimism, Kate Crawford is more critical. She argues that if AI systems are seen more reliable and rational than any human expert, able to take the best possible action, then it suggests that they should be trusted to make high-stakes decisions in health, education, and criminal justice. In this research, we are optimistic about the use of AI in design, but we are also cautious because there is no best action in design. People have long been fascinated by the idea that an inanimate object can become intelligent. The foundations of modern AI can be found in classical philosophy, which describes thinking as a symbolic system. Since the 1950s, research in AI is studying how machines can reason, represent knowledge, plan, learn, process natural language, perceive objects, and manipulate them. In my doctoral thesis, I developed an architectural design crowdsourcing software, framework, and process. I have demonstrated that architectural design could be produced using crowdsourcing based on professional architects and non-specialists. Coupled with AI methods, the algorithmic design process offers excellent potential to improve and automate architectural design. These computer abilities raise new questions about the place of human in an AI-based design process. Our project seeks new knowledge regarding human interaction with AI. The research will unfold through the following research question. What methods can provide an effective interface between humans and a generative AI in a design process? Now, we will go back in time to AI research that was concerned with finding scientific and computer methods of solving design problems. Then I will overview several new AI methods used to generate artifacts, specifically machine learning based on neural networks. Following the Design Methods Conference held in 1962, there has been a broad consensus amongst scholars that the systemic design process consists of 3 steps. The analysis step includes collecting, classifying, mapping the relationships between factors, articulating the problem specifications, and reaching an agreement. In the synthesis step, creative thinking is applied to create partial solutions. And finally, in the evaluation step, the solution is judged by various evaluation methods. However, in practice, the design process has interdependent links between decisions. After changes are made to the design elements, previous decisions must be re-evaluated. For example, changing external walls would also require changing the roof. This will lead to more changes in the design in a circular manner. Based on these findings, T.A. Marcus added one more level to the design process. This higher level consisted of the following 3 components: preliminary, sketch, and detailed design. This approach is the foundation of RIBA plan of work that is the most accepted design process in architecture. In his book, The Science of the Artificial, Herbert Simon introduced the idea that design is a search process in a solution space. Also, he argued that design is a challenging problem from a computer science perspective, since the designer does not have all the required information to create an optimal solution. Additionally, sometimes design requirements conflict. Therefore, design problems are considered wicked problems and ill-defined. Design solutions are not absolute and correct, but an optimized compromise that is a good fit. Extending the notion that design is an exploration of the solution space, I developed an algorithmic design method. This method relies on crowdsourcing, which provides a community with the ability to produce designs together with experts. The design process is based on RIBA's approach, but instead of structuring it around the cognitive process of the designer, it regards a human as a black box that receives input and produces output. The design process starts with an input of a brief, here in the red. Then the brief is explored through design, resulting in a variety of artifacts for many architects. In the selection process, the community chooses the best designs. Finally, in the review phase, feedback is provided. This is critical information that is essential for the next iteration and also updates the problem space. The final design is a product of the wisdom of the crowds and a collective intelligence that emerges due to the collaboration. For the current project, we will extend this model by integrating AI components into it. Today, we are fascinated by artificial neural networks that are capable of machine learning. A neural network is a computer system inspired by the biological neural network found in brains. They are made out of neurons, which are organized in layers, and the layers are connected. In this example, we have an image classification neural network. It was trained to identify cats or dogs. There is an input layer that receives an image. There are 2 neurons on the output layer. One that outputs the chances that there is a cat in the image, and the other, the possibility of a dog. Although such a neural network is relatively simple. They require a large labeled data set of cat and dog photos. To create this data set, human labor is needed, which is extremely expensive. The introduction of generative adversarial networks, called also GANs, by Goodfellow and colleagues, allowed generative neural networks to be trained by small data sets. Using different approaches, researchers have created some exciting new methods of creating architectural designs. A GAN is made out of two neural networks contesting with each other in a zero-sum game. For example, Jones and Bonafila created GAN growth. Here, that's the example of GAN growth, a GAN that produces fake Van Gogh pictures. Similarly, it is possible to make architectural images. This is another kind of GAN. Style GAN is a neural network that learns to identify. Style GAN is a neural network that learns to identify an image style and apply it on other images. In this example, human face style is applied to different human faces, creating faces of people who do not exist. Another GAN approach is pix-to-pix. This is a conditional GAN that is trained for a specific task. For example, building images, we can see here an example, were classified into architectural elements, and the network was trained to generate building images from the architectural layout. Let's see an example. So we get a random layout. We can change the layout. For example, we add a larger door. We click process and the image is updating with a larger door. Now we try to add some striped windows in modern style. Let's see what it creates. Then we get this classic facade with longer windows. Now I'm adding a background. So in this situation, the network produces a distorted image, and it is rather disappointing. So human designers use natural language to analyze the problem space and evaluate designs by discussing them. After gaining an understanding, the designers produce solutions and express them using sketches and natural language. Following this notion, OpenAI introduced an adaptive image generation AI model called DALL-E that uses transformer deep learning approach to convert natural language into images. DALL-E is capable of combining unrelated concepts in a plausible way that is creative. For example, a photo of a computer from 1910s produced novel computer designs. You may see more examples in the video, like a street in Israel, a storefront with specific text on it, even more complex examples like a living room having two olive armchairs with a painting of a windmill. The painting is mounted over a traditional fireplace. DALL-E is remarkable as an AI that can convert natural language into images in a way that makes sense and is also creative. We can see TVs from the 19th century. So I want to ask you, is this similar to design work? Can a client express a design problem in natural language, and the designer who understands the situation produces multiple sketches of novel artifacts? So we started developing an AI model that produces architectural sketches. We chose tensor flows, deep convolutional generative adversarial network. We trained the GAN based on a training set made out of architectural sketches, and you can see now the sketches that we used. The set included images of sketches that depict buildings rendered using pencils and pens. We also classified them by elevations, sections, plans, and perspectives. And you can see now the training set of perspectives. We trained our model running our code. Every learning iteration produced 25 images that were saved for documentation. Here we can see the learning process by combining all 15,000 images into a 1-minute video. We can see that the model tries to produce architectural sketches. It slowly adapts and discovers architectural geometric features. So I think this part of the learning is the most interesting because the images are rather abstract. And to the end, we will see that it tries to actually guess the images from the training set. But a second before it guesses the images, it is very, I think this is the interesting part. So here we get images that are similar to the training set. The trained model produced several new architectural images based on the different training sets. However, we had little control over the design. Also, with this method, the design was not related to the design requirements. The set images suggesting that the results were overfitting. Together with conclusions from the literature review, we found that generative AI is limited. First, it is a statistical function to produce fake artifacts. A useful method must be coupled with design logic. Second, the interaction did not seem intelligent to us. A phenomenon called AI effect explains this. Challenges like text recognition or the understanding of spoken language that in the past were considered AI are nowadays not perceived as AI anymore. Our perception of an intelligent computer is dynamic and changes with progress. In science fiction movies like Metropolis, AI has the body of a robot as an interface. Although we have cool robots in the lab, we are interested in the essence of the intelligent experience, a conversational interface. It seems that in order for a computer system to appear intelligent in movies, it must communicate with natural language. This approach is wonderfully expressed in the 2013 movie Her by Spike Jonze. In the movie, the protagonist develops a relationship with Samantha, an AI virtual assistant, through conversation. While general AI, like Samantha, is not our goal, we believe that exploring AI through conversation is essential. We argue that conversational AI could be introduced as a component of a human-centered AI design process. To explore how AI can integrate as a collaborator in the design process, we use the crowdsourcing design model. We extend the crowdsourcing design process model and integrate AI into the design process by placing AI components as an interface between clients and designers to improve the process. In our case, one could think of an AI as a helper or communicator of the design. The first step is to define the problem space. A brief could be derived from a conversation using natural language processing and a chatbot. In the next phase, designers use AI to generate partial design recommendations. With more advanced AI, autonomous generators could produce designs alongside of humans. Selection is a straightforward but critical task. During this phase, humans select the best designs. Finally, humans are asked to review the design. This phase is critical for a collaborative design process. Here, we suggest using NLP with a chatbot interface to perform design review conversation. We are currently concentrating on the first step, the design conversation, the collection of requirements and modeling of the design space, the problem space, sorry. Our current goal is to build a design chatbot. To learn how people discuss a design with an AI, we use the Wizard of Oz research method. The idea underlying the Wizard of Oz method is that a human operator is behind the scenes of a operates behind the scenes of a sophisticated machine in a way that an observer may assume that it is automatic and mechanical. In this way, we can learn how people react, converse with a chatbot without building a working prototype. We started to talk with people about their dream house while recording their reactions. On this screen, the wizard acts as the AI. It has some predefined questions and responses. The "I'm sorry, but I didn't understand what you said" message is our favorite. In the lock screen, we can see the conversation and the subject reaction. Based on the insights and knowledge from the experiments, we will model a conversational chatbot using a commercial chatbot platform and GPT-3. GPT-3 is the world-leading natural language model. So to summarize, with the development of advanced AI, digital design techniques that use these methods are becoming increasingly popular. This research will provide valuable insights into how AI could be used with humans in a design process. And that's it. Thank you.
Questions, comments are welcome. Critics?
I can start with a question. So thank you, Jonathan, for a wonderful talk. I wonder, it seems so very positive what you said, like very easy. Like we did this, we're going to do that, everything is going to be easy. I wonder what are the limitations of where is the, where is the problem? Where is the big problem of this, of AI?
Well, the biggest problem is that it doesn't work, and we do not have yet the capabilities to produce a real understanding with the computer. It doesn't understand, it just mimics the input that it gets from the training sets. So we try to go around this problem by actually mimicking a discussion and saving some kind of unstructured data structure of the problem space that at the end could be somehow communicated to designers. So we don't care about the computer really understanding what the design problem is, just acting upon it to create design solutions that makes to us sense. So this is the biggest challenge.
So you are part of it. I mean, it makes to you sense. It's not making for the computer sense.
No, I don't believe that we are currently advanced enough that the computer could actually make sense of such a complex problem. And basically, all the machine learning technologies, they demonstrate how a computer can fake something, but there is no real understanding behind that. A computer does not understand.
I have a question. Hi.
Hi, Adi. By the way, Adi was a participant in the crowdsourcing experiments at the Tel Aviv University.
I was his student, and we loved the lesson. We used to sketch and design all the time, much more than we did in the studio. So my question is, I saw the sketching and I think it's beautiful how you create a machine that know how to sketch, but it wasn't that clear. You want the computer to sketch as he is thinking about an idea and then to create plans so it can be designed in the real life?
Well, the preliminary exploration that we did, and with the deep convolutional generative adversarial network, taught us that it's not that easy to make architectural designs with an AI. It is not complicated enough to produce solutions that make sense. Also, other technologies that were demonstrated in the recent years, like the work that they did in Harvard and other things in China, are really impressive, but the design is not good. So it fakes images of architectural plans, and it is not a good plan. It is not good architecture. It doesn't take into consideration many other parameters that are important. So to do that, to produce an AI that looks at all the requirements, we must go one step before in the process and get an understanding or collect all the information that is required for solving this problem. And we now try to focus on collecting this information with natural language and having a conversation with the users. And I don't know yet how and if we will be able to convert this information into architectural sketches. We didn't do that yet.
Thank you.
If it's possible, I'd like to elaborate. I'm sure that Adi and her friends and her colleague students had a great time sketching. I would like to suggest that maybe you could narrow up the scope of the design problem. I know, Jonathan, you know my work on crowdsourcing, where we actually did a kind of a, first attempt on this AI thing, where we tried to let the computer design very small apartments where all of them had very, the same area, the same volume, same interior components and so forth. And then we use the crowdsourcing to evaluate these apartments and to redo them and try to create a better, not the best, but better opportunities. So what we realized was that once you try to widen the scope, like say, okay, apartment with how many rooms, where is the apartment? How many apartments do you actually have in the building? Where is the building located? If you're, adding more complexity, then, it's really, really difficult to find a good solution that even the crowdsourcing could help you. So maybe try to do it step by step. And because when I saw these beautiful that you showed us, I'm quite sure that, it's like enormous amount of data. And then when you're trying to figure out, these beautiful sketches, what kind of actual architecture evaluation you could get, it's, I think for now, maybe it's still impossible, like you said. So maybe try to have a smaller scope of a design problem.
Well, and I use crowdsourcing I try to develop a process that addresses architectural design problems. And the big advantage doing that instead of AI is that you deal with human people that understand what you want from them. And they are also architects, so they have the tacit knowledge of how to solve these design problems. So it's much easier working with people and letting them solve problems. We are concerned with the complexity of the architectural design problem, which is a real challenge. And we focus our efforts on modeling the problem space only. We are not concerned in this step with the solution. We just want to know what is needed. This is not less important than providing solutions. And in our literature review, we saw many people that are interested in solving the architectural problem. And then they look at it as, I think, it's a set of 7 kind of problems. We have a layout problem, we have an elevation problem, we have a program problem, and you can apply computer methods and algorithms to solve these problems as mathematical as possible, and you can optimize them. But no one solves the whole problem, and only humans do that today. They understand the problem in another way. So the first step is just understanding what needs to be done.
I have a question regarding the data sets, the drawings that you train the model according to. How do you choose the limits of that data sets, given that the data set that you choose really kind of inscribe the results you will get? So there's an inherent kind of decision or bias already in the definition of the data set. So how do you define the boundaries of what is the data set?
Yes, this is a serious problem in AI. There is a bias built into these systems. And this bias is a cultural bias that comes from the data set, from images. For example, that there are AI systems that if you ask them to draw a human in the kitchen, they will draw a woman. And there is today a lot of research trying to mitigate this kind of bias that is existing in these methods. So it is absolutely a problem, and this is one of the reasons that we are trying to look at the problem from a different angle.
I also would love to ask something.
Thank you.
First of all,
Yes.
Hi, Karen Lee.
hi, everyone. So nice to see everyone here. And Jonathan, thank you so much for such a thought-provoking presentation. And I think I have to say to me, this, although, and I know a lot about your work, but to me, the way you're wrapping up this project seems less as the construct of an architectural machine per se, but more as an attempt to construct an architectural machine that supports a collaborative design process. So in a way, you're not using the GANs to create some ideal architecture and then find a way to assess it, as you kind of discussed a few minutes ago, but rather to kind of throw this stone into the pond of a process. And I think that raises a question. So you're basically taking a bunch of designers and counterparting them with a machine, which is either a troublemaker or the best problem solver. We don't know, right? And as such, I think the question is what's the role of this machine in the process? It's kind of a branch of human-machine collaboration, because the humans are plurals, right? There are a lot of people in the machine. So is it a decision aid? Is it a propeller of the process? What's the relationship going to be? And what's the dynamic going to be? I think that seems to be the real question here.
Yes. First, thank you. You're absolutely right. This is the challenge to understand what kind of AI can be in the different design stages. So in the beginning, we have a conversational AI that just extracts design requirements and ideas and maybe abstract concepts from people. There is a big opportunity in developing such a design AI chatbot because it allows us to distribute the architect and having a conversation maybe with thousands of people and gaining from them the information of what kind of design project we need to make. This isn't something that we know to do today, and there is a lot of writing on that. So first, understanding the design problem. Then we break it. There is another part that we can generate from the design problem solution candidates in two ways. One way is to use a recommender. It means that the AI produces some design candidates, and the human designer selects the right designs and integrate them into his design. The other way, which is much more advanced, is to have an autonomous design agent that produces designs. Then I believe, and it mustn't be like that humans choose the best designs. And this is a method that I developed in my doctoral thesis. Finally, when after design candidates are selected, we need to iterate. Before we iterate, we need to have a review conversation with the clients and the community. And we need to gain information by natural language. People express these ideas by speaking. And it is a big challenge to take all this information that is provided in natural language, to aggregate it and to structure it, not only in a way that makes sense to AI, but also in a sense that in a way that makes sense to human designers that can build upon it. So these are the ways that I think that AI could be integrated in a human-centric design process, but not an automated AI design process.
I do have a question. I do have a question. You know, like I think I know we've been discussing that a lot, but I see here Carol and I see our colleagues from industrial design and from urban planning and from landscape architecture, and I'm thinking about something that bothers me a little bit about all this is the fact that at some point somebody has decided to call these intelligent systems, right? And I'm still trying to figure out, how did we reach a point where we're talking about smart cities and what is smart about the smart cities, or what is artificial intelligence, and what is actually the degree of intelligence in this? I'm curious about this. I'm thinking that there should be a project, of trying to uncover when in time in history they started to be a use of those terms like intelligence, right? And I remember that as you were preparing this talk, you actually went back to I think it was in Dortmund that you okay, that's where the first time you claim for the first time the term artificial intelligence has been used. And I was wondering if like how they came up with this. Like, why do you think that this term became available and not available, but I would say legitimate in a discourse?
I'm not an historian of AI, and I think it is a human fantasy that goes many years back to have an intelligent robot. And computer scientists tried to create such an intelligent machine. It had ups and downs, right? We had this old good-fashioned AI research, And then came out movies like Odyssey 2001 with the evil AI that kills humans. So funding stopped to AI projects. And then there was a part in the AI history of the winter of AI. Then it came back in the 80s and it also failed. And then was another winter. And now with machine learning and Google creating AlphaGo, the computer that won the Go game, and many new machine learning methods, then now everyone is excited again. But intelligence is a philosophical concept. I think in smart cities, intelligence is used to show a kind of power that the organization or the city has on the residents. It's not really intelligent, it's not smart. It just appears as smart. And I think this notion is what directs my research, because I think that what we do is not intelligent in any way. It just appears to be intelligent.
Yeah.
And we like it to appear to be intelligent. So we fake it.
Aaron, can I ask a question?
Sure, and then there is also Dan.
I can wait.
Tom, before me, please.
Thank you, Dan. Johnny, thank you for a great presentation, super insightful and very well presented. I have a question or a suggestion, maybe, because what you presented, if you do succeed, let's say in a best case scenario, you do succeed, so you can imitate the architect, or at least the beginning of the architectural conversation with the client. And then if you do even more than that, you augment that. So you have a better conversation, or you produce better results than what the client and an architect can achieve. But the question is, and maybe I can suggest a question, is asking what can we uncover from that relationship using AI? To say, like, because design is somewhat an unknown or an uncertainty. It's not an art, it's not engineering. Nobody really can pinpoint exactly what architectural design is. And I wonder, maybe you can use your tool to uncover the hidden knowledge in that respect. For those, I guess, Simon received the Nobel Prize. Maybe there's some questions here that are not yet answered, even questioned.
I didn't understand the question. By the way, thank you for helping me to prepare this presentation. What is exactly the question?
The question is, I think it's not a question, it's a statement. And the statement is, I think there's an unquestioned question. Is there something you didn't ask yet? Is what can you uncover in the process of design using your tools? That's what I'm saying. And I think this is left not even unanswered, but unquestioned, because you assume you can imitate, but what are you imitating exactly, right? Using AI. What is the worth of duplicating what architects do by using machines? And I wonder if you can uncover something in the design process using such tools.
You know, I mean, I'm sorry, but I need to say a word about this. Although I'm not the one supposed to answer this, but you know, I feel at home. One thing that I suggested to Jonathan early on is that, you know, when you look at the discussion between, you know, Le Corbusier and Mies van der Rohe, and you can see two very different visions about architecture, you know, about materiality, about, you know, thinking about the definition of space, etc. And so one of my first questions when Jonathan was writing his research proposal, I asked him, you know, okay, so if I take a Mies project and I take a core project, will you be able to do this kind of synthesis of what is, like, you know, a hybrid of those two? Like, I was interested to know about that. And, you know, I'm not sure if there is any value to that, but I thought that was, you know, that something that was interesting was this kind of mixing of the things, or a remix of the things. But I'm not sure if it's relevant.
Well, There are so many interesting machine learning methods today, and these are really exciting, but I focus on the design process, and there are many questions that I have no answers to them, and I definitely will think upon what you said. And thank you for this proposal, an idea.
Jonathan, in your talk, you showed this diagram of the process that you're using, and one of the last parts of the process was a diamond-shaped image where you make this decision of evaluating the design up to that point, and if it's good, it kind of goes to the end, and if it doesn't, it goes back to the beginning, and the process cycles upon itself. My feeling is that, and this is not my field, artificial intelligence and computer-generated design is really not my field. I come from a generation that designs with a pencil and paper. But I think that this is a holy grail that that is going to be extremely difficult to resolve. And as a metaphor, I would refer you to a project which we're designing at the moment. It's a project of 156 identical apartments designed in 1930s as workers' housing. And we're in the process of doing a major restoration renovation project. You would think that 156 people who have bought apartments in a complex, in the same complex, where each apartment, all the apartments are absolutely identical, and they're now given the opportunity to renovate their apartments, and there are no two apartments which are identical. Every single one of the 156 people comes with their own sense of aesthetic, their own particular program, what they need, what they like, their dreams, their hopes, their aspirations. And therefore, I imagine that in there's an attempt to automate or to translate the process of architectural design into something which is done by a machine on rational decisions. We will not be able to achieve anything but the lowest common denominator, because we will finally have to enter an endless loop where every single individual has got a unique solution. And that's why we build the cities the way we build them. It is not a rational process. It may be rational for one person, but for the next person, that same design process is not rational because they have different values, different aspirations. And so it's not a question. It's just an it's a sense of a feedback to what I've heard this afternoon, which is fascinating for me because I don't come from this field.
Thank you for this question. And this is something that is outside of the scope of my doctoral research, because it is a separate problem to decide when a design is good enough, that we stop iterating and developing the design. However, I did do a preliminary research to see in a simulation how many iterations would be required to create a design that converges. In this design process, we explore the solution space, and then the selected solutions are the input for the next iteration. We don't start from the beginning. And there is a phenomenon of design fixation in humans. So when you get a design and you develop it, you are not very creative normally, or people do not tend to be creative. So there is a convergence of design possibilities over time. And at a certain point, I calculated it, and it happens about 10 design iterations, the design does not change a lot. So basically, I think, I have this hypothesis that I need to check, that this process can stop after 10 iterations. then a detailed design process needs to continue, because the designs are not really developed. They are just an idea of design. However, if you connect people in the right way and you create a collaborative design process, there is a social phenomenon that is called collective intelligence. This collective intelligence comes out from collaboration. It has been shown in psychology research that if a group that has better communication and basically is made out of women, they produce artifacts that the intelligence is more than the sum of the intelligence of the group. So this is, people believe, a real phenomenon. So if you have a design that goes throughout several designers and everyone is adding something unique and personal to this design, I can argue that maybe something with the collective intelligence is produced in this process. And if we add also some AI into it, and AI also collaborates in this process, this might be a collective intelligence, a product of collective intelligence of humans and machines. But this is only a hypothesis in this stage.
עוד שאלות?
לא.
אלון.
היי יונתן, כיף לשמוע, שווה עוד קצת הסברים בדרך, ולכן אני רוצה לשאול שאלה שהיא יותר עקרונית, מתוך הנחה שאני באה באמת מתחום אחר לחלוטין. אתה מדבר בעצם, בכל הדברים שאתה הראית, עדיין יש לנו human-centered process. זאת אומרת, אתה נותן לנו, אתה דיברת גם על האפשרות הזאת של hurting the decision space. עכשיו, השאלה היא, אם יש כאן משהו בכל התהליך, אתה מדבר על הנושא של יחיד, לעומת הנושא של קולקטיב, ויש את הנושא של ללמוד, אולי כמו שתום הציע, ללמוד את התהליך של הדיזיין של יחיד, וללמוד את התהליך של דיזיין של קולקטיב. אבל אם יש לנו בכלל את האפשרות התיאורטית, שנאמר, כמו שאנחנו מדברים בתחום של מכוניות אוטונומיות, שיש לנו 5 שלבים, והשלב, יש הבדל גדול בין השלב הרביעי לחמישי, שבו המערכת כולה יכולה להסתדר בלי אנשים. אם יש לנו בכלל שאיפה להגיע למצב שבו ה-human-centered נעלם מתוך המערכת, האם זה חלק מתוך המחקר שלך או של אחרים, שאנחנו יכולים באמת לייצר מצב של אופטימציה של פתרונות?
זאת שאלה מאוד, מאוד טובה וגם מאוד מורכבת. ברור שאיזשהו אלגוריתם שאנחנו חושבים שהוא, כמו שקייט קרופורד אומרת, שהוא יותר חכם מאיתנו, ונדמה לנו שהוא יודע לקבל יותר החלטות טובות, אז הוא בעצם סוג של מחליט עבורנו איך הערים והבתים שלנו ייראו, עבור כל אחד מאיתנו. אני חושב שאנחנו לא צריכים בכלל ללכת לכיוון הזה של מכונה שהיא יותר חכמה מאיתנו. אני חושב שהמכונה צריכה לעזור לנו גם להבין מה אנחנו רוצים, וזה בתהליך של השיחה, וגם לעזור לנו לתת פתרונות יותר טובים, אבל לא לוותר על השליטה ברכב שאנחנו נוהגים בו. לא, בכלל לא לאבד את השליטה. המכונות האלה לא יודעות לייצר, לדעתי, דברים שהם יצירתיים, חדשים, בטעות. כן, שיש להם מכונת טעות, אנחנו קוראים לזה באג. אבל כשאנחנו עושים טעות בסטודיו, אנחנו יודעים לפתח את זה למשהו יצירתי וחדש. אז אני לא מאמין שאנחנו צריכים ללכת כל כך רחוק ולתת ל-AI להתחיל לארגן לנו את הערים ואת הבתים, ולוותר על כל השליטה ועל היצירתיות שלנו.
ואיך אנחנו מחליטים על רמות השליטה? טוב, זה בעצם אולי נושא שהוא באמת כבר...
קודם אנחנו צריכים לייצר את הטכנולוגיה, ואז אנחנו יכולים להחליט לגביה. הייתי מאוד פוסט-הומניסט בדעות שלי בהתחלה, אבל הבנתי שלאנשים יש מידע, שגם אדריכלים אין להם את המידע הזה. אותם לקוחות שלנו, שאנחנו צריכים להבין מהם מה הם צריכים, אנחנו כאדריכלים לא יודעים את זה, ואנחנו צריכים גם שיטות להבין את הלקוחות שלנו. ואם אנחנו מתכננים עירונים, אנחנו צריכים להבין מה 1,000 אנשים רוצים, כדי לתת להם פתרונות דיזיין טובים יותר. ואם הפוקוס שלנו יהיה להבין, אז זה יהיה כבר טוב. אחר כך ש-AI, לא יודע, אחרים יעשו את האלגוריתמים הגנרטיביים האלה, אני פחות מתעניין בזה.
אוקיי, תודה.
יפה. היות וכבר 3:30, אלא אם כן יש מישהו שיש לו שאלה דחופה, אני מציע שנסגור את המפגש. יש שאלה דחופה? אוקיי. יונתן, תודה רבה. תודה רבה לכל המשתתפים, לכל השואלים ולכל המשתתפים. ואנחנו נתראה שבוע הבא ונשלח כבר אימייל לפגישות הבאות. תודה.
להתראות, תודה.
תודה רבה, היה מעולה.